Hello, in this video we will conclude discussion on test of significance by talking about how to conclude the results of a test of significance. So that is our primary learning objective. Actually, it's our only learning objective. So let's just review. We're talking about this Tootsie Roll Pop example where we have the null hypothesis that on average it takes 3 licks to get to the center of a Tootsie Roll Pop. We have our HA, which says on average our claim is that it takes more than 3 licks to get to the center of a Tootsie Roll Pop. We're dealing with a scenario where mu is greater than 3, so that implies that when we calculate our p-value is going to come from the probability that z is greater than or equal to little z, which is 3. So actually I'll write both of these up here so that you can see that they're equivalent. Not 3, sorry, it's equal to, 35.17 minus 3 over sigma over radical 2, which was 32 divided by square root of 6. And if you plug that into the calculator, that's p of z being greater than or equal to 2.46. So this is step 1, this is step 2, step 3 is to find the z-statistic, which we found here, and then step 4 is to find the p-value. And so let's talk about the first method of doing that. Okay, this is the method that is very thorough. We'll use table A. So remember that the z-statistic is a z-score, which means it lives on the standard normal distribution. So to use table A, we need to involve the cumulative proportion. The probability that z is greater than or equal to 2.46, so this is 2.46, is going to be this area. But to use table A, we actually need to look at this area, because that's what table A gives us, and then subtract that from 1. So we're going to look at the cumulative proportion of 2.46. So we'll pull up table A. So we'll find z-score 2.46, 2.4, 0, 1, 2, 3, 4, 5, 6. So it's 0.9931. Alright, so that's equal to 0.9931. And so the probability that z is greater than or equal to 2.46 is equal to 1 minus 0.9931, which is equal to 0.0069. And this is also equal to the probability that a randomly selected Tootsie Roll Pop takes more than or equal to 35.17 licks to get to the center of a Tootsie Roll Pop. So what does this very small p-value imply? Well, this very small p-value implies that our evidence is very strong, but it's very strong in favor of HA, because this suggests that our 35 is so far away from our 3, which we know we can compare numerically, yes, but test of significance sort of supports that thought. And how do we conclude? Well, we can conclude by saying we reject H0 in favor of HA. So note, we do not say we accept HA, okay? All HA says is that mu is greater than 3, which means that mu can really be any value greater than 3, so we can't accept HA. all we can do is reject H0 in favor of HA, since HA is not really specific enough to accept. Additionally, if the p-value was not large, then what we would say is not that we reject HA, because again, HA could be more, it could, an alternative mu could be more specific, right? Just because evidence does not support HA doesn't mean it's false. So what we would say is do not reject H0. And so these are the two types of conclusions we can make based off a test of significance. We can either reject H0 in favor of HA, or we do not reject H0. All right, so now let's talk about significance levels, because this is really what you see all the time when you read papers that use statistics. Okay, so alpha is the symbol for significance level. And we compare this with our p-value. So if our p-value is less than alpha, then we claim our p-value is statistically significant at level alpha. Okay, some common alpha are 0.01 and 0.05. You'll see 0.05 being used all the time in our text. And so if p is less than or equal to 0.5, then what we're claiming is that alpha is equal to 0.05. Okay, so this upper bound is always going to be our level of statistical significance. And often we'll care less about the actual p-value and more about whether it's less than or equal to our alpha. Okay, so let's remember that we have this Tootsie Roll example where x bar is equal to 35.17. We have our z-score, which is 2.46. We have our p-value, which is 0.069, and this is statistically significant at level alpha is equal to 0.01. Of the two that are listed here, that's which one it is not most less than. I guess what I want to say is that we choose the alpha that is larger than p, but smaller than all other alpha, if that makes sense. So it's like the least upper bound that we can use. So how do we find this alpha using table C? Well, I'll write down the steps. Okay, so again, our steps are both one and two-sided p-values for z star are at the bottom. So we'll look there. And then we look for where our z-statistic lives compared to the z-star. Remember, there's a third row there that contain critical values, which are more important when we're talking about confidence intervals. But when we're talking about tests of significance, we can use z-star to determine where our z-statistic lives, and then that means our p-value is statistically significant at the level alpha, which is to the left. Remember, because the values in the table get larger from left to right. Okay, so let's just go back up here. Remember, our p-value is 0.0069. Our z-score is 2.46. So let's go back to table C. Okay, So we're looking at the bottom rows. We're looking for where 2.46 lives. And notice that 2.46 lives between these two values. Okay? And so what does that mean? Well, we have a one-sided argument. Okay, our alternative is one-sided, which means we're looking at this row. And we're looking at the p-value associated with our one-sided argument. And we want to see where our z is in terms of its p. And we know that it's 0.0069 or approximately 0.01. Oh, actually, that doesn't make sense. Sorry. 2.46 is here, right here. So 0.0069 is approximately 0.01, but still less than it. So this location agrees with the p-value we found. And so notice that our p-value is less than the 0.01. So what this row is designating is various significance levels. Okay? And your p-value is going to be less than the alpha to the left, and all other alphas to the left, but this is the one that we care about. It's the one immediately to the left. So to summarize this video, we went through the steps of a test of significance again. 1, 2, 3, 4. Okay, and then step 5 was to figure out what the level of significance was, and to conclude. We concluded that we do reject H0 in favor of HA, and that our significance level is alpha equals 0.01. Okay, and also in this video we learned how to read Table C to determine what our statistical significance level is.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.